This example provides an opportunity for us to apply our understanding of trigonometry to solve a complicated problem. The question says the angle of elevation from D to B is 30 degrees. So if we're standing at point D and we look up to point B, this angle of elevation in here is 30 degrees. It also says the angle of elevation from D to C is 45 degrees. So standing at D and then looking up to C is 45 degrees. AD is 20 metres. This measurement along the bottom is 20 metres. Find the distance from B to C, which is this distance in here. Now you'll notice that that is not the side of a right-angled triangle. So we're going to have to do a couple of extra steps and a few more calculations to be able to find this side length BC using right-angled triangle trigonometry. First thing we want to do is look to see if we could find some measurements in the same direction. If we knew some other measurements, we would be able to do some calculations and find this missing length. So this distance from A to C is in the same direction, and so is this distance from A to B. Both of those measurements, A to C here and A to B, are sides of right-angled triangles, so we would be able to find both of those distances. If we knew how long the longer distance was and how long the shorter distance was, we could subtract the short distance from the long one, and that would leave us with our side BC. So we're going to have to do a few calculations to be able to find out what each of these sides are to calculate the distance between B and C. So let's start by calculating AC. Draw a sketch up here so we can see what we're calculating. We have 45 degrees angle of elevation, AC, and our right angle, and we know the base is 20 meters. Let's call this opposite side X. So we start by labeling our sides. We have opposite and adjacent. So we use the tangent ratio. Tan theta equals opposite over adjacent. We substitute in our values. Tan of 45 equals opposite was X over adjacent was 20. You can rearrange this formula to solve for X by multiplying this side by 20 and multiplying this side by 20. So we have 20 tan 45 equal to X. And pop that in your calculator, and that will give us X is equal to 20 meters, which does make sense if we have a look at it because we have 45 degrees here. This is 90 degrees, so this other angle has to be 45 degrees. If the two angles are the same in the bottom corners, then it's an isosceles triangle. So it makes sense that this side would also be 20 meters long. So we know the length of the side AC is 20 meters. We can call it AC. Let's calculate from the smaller triangle. We'll draw a sketch of it over here. DAB. We know this side is 20 meters, and we know our angle of elevation is 30 degrees. And we're trying to find the opposite side over here. Opposite. We have adjacent. And so we use the tangent ratio. Tan theta equals opposite over adjacent. Substitute in our values. We have tan 30 equals y over 20. We can isolate our y by multiplying both sides by 20. And we have 20 tan 30 equals y. Or y is equal to 11.55 meters. And we can write that as BA now, or AB. Because that's our side length AB. So we have the whole distance from A to C is 20 meters. Circle that. And our whole distance from A to B is 11.5 meters. So to find the difference between these 2 points, so the side length BC, that's going to be equal to AC. Take away AB, which is 20 minus 11.55, which gives us 8.45 meters. And the question does ask us to round off to 1 decimal place, so we need to round that up to 8.5 meters. There you have it. So the distance between points B and C is 8.5 meters.